Elasticity or mechanical properties of solids. It's a very small topic, Mains, I can say. Advanced probability is a bit low. If at all any question comes, it comes as a part of a big problem. Okay. So elasticity or mechanical properties of solids. Mechanical properties of solids. Let us start. First, few things we need to understand. The definitions are clearly given in the synopsis that I gave. I'm not going to discuss much. Let me go through quickly. Rigid body. Rigid body. Okay, what is rigid body? A body which will not deform under any amount of force. Stress is given. You don't know what is stress. Later we'll discuss, but for time being, you take it as force. What is rigid body? If you apply any amount of force, the body will never deform. In reality, in the world, there is no rigid body. Diamond can be close to rigid body, but still, diamond also will break at some what? Force. Okay, right. Next thing, deforming force. Definition, everything is given in the textbook. Check it. Deforming force. This is the definition of this deforming force. I directly took it from State Board textbook, 11th class. Okay. Yeah. The external force which produces change in the body is called deforming force. Suppose when you take elasticity, what we do is that we study elastic behavior of materials. What we do, we take the body and we apply some force. It will deform. It will change its shape, right? So that's what we're going to study right now. So the force which is applied on the body, the external force which produces change in the body is called as deforming force. Okay. Next one. Next one is elasticity. Elasticity. Definitions are clearly there. You can see the synopsis, right? NCRT, I do directly look at the property of the body by virtue of which it will tend to regain its original size and shape when this deforming force is removed. When applied force or is called as elasticity. By this property, it will come back to original thing. Elastic body is the body which will regain, is called as elastic body. The property is called as elasticity. The next one is plasticity. What is plasticity? The property of the body by virtue of which it will not regain its original size and shape after deforming force is removed is called as plasticity property, and the body is plastic body. And observe, we have three different bodies: rigid body, elastic body, plastic body. Okay, rigid body will not change its size and shape under any amount of force. There is no change, fixed. Body shape is fixed. But in reality, it doesn't happen. Either body will deform and come back, that is elasticity. A body will deform and will never come back, it's called as plasticity. And body is plastic body. Now, you need to understand the next thing is restoring force. What is restoring force? In elastic bodies, assume there is a rod or rubber band or something. If you apply force, let us assume I'm going to apply force on both sides. It will elongate. It will elongate. After this elongation, once I remove the external force, when I remove the external force, what happens? Internally, there will be a force to bring back to original size and shape. So the internal force which is developed to bring back the body is called as restoring force. The internally developed force is called as restoring force. Remember that when the body is there, which is not being deformed, that means I'm not applying any amount of force. I'm not deforming it. I'm keeping it rest. Then the restoring force won't be there. When you apply external force, okay, or whatever, when the body got deformed, then only restoring force will be developed. Okay, right. Okay, that is restoring force. You need to understand rigid body, deforming force, elasticity, plasticity, elastic body, plastic body, restoring force. Okay, now new concept from this point onwards, we need to focus stress. Stress we take. Okay, the restoring force per unit area. Wait, don't get confused. There are two forces: the externally applied force, internally developed force. So stress is restoring force per unit area. That means internally developed. Stress is equal to restoring force per unit area. Restoring force per unit area, that's it. Okay. Units is Newton per meter square, or M L power -1 T power -2. Yeah, these are dimensions. Okay. Stress is having units of pressure. Generally, we won't use pressure because pressure and stress are slightly different. Not theirs, not same. So we use Newton per meter square. That's it. Stress, restoring force per unit area. Now concentrate. When you take a body, you can deform the body in multiple ways. Okay, you can deform the body in multiple ways. The first one, observe, the first one is you can stretch it and elongate, or you can compress it like this. Observe carefully. In this case, either elongation or compression, both are along the length. Both are along the length, right? This kind of restoring force per unit area is called as longitudinal. Right? Longitudinal stress. Try to understand a little bit is there. This is compressive. This can be called as elongative, but not exactly elongative. We call it as tensile. This is compressive. This is tensile. Compression, elongation, but instead of elongation, we use the word tensile. Okay? Right. Now, if you take the case of a body like this, the random body, if you apply force or from all sides, not only along length or something, from all sides, I'm taking, sorry, random shaped body. I'm compressing from all possible sides, okay? Like this. Perpendicular to the body, like this, okay? Now, the body will deform. Now, body will deform. 1 minute. It will decrease its volume. In this case, the decrement in volume is not along the length, it is total. So if you have this kind of deformation, the stress will be bulk stress. And one more is also there. Suppose if you take a body like this, assume, and it is being rigidly, just a minute, and it is rigidly fixed to the ground, assume, okay? Just a minute. Yeah. A body which is rigidly fixed to the ground. Now, if you apply force on top of it, like this, tangential, the body will bit deform, right? The topmost point will slightly move towards right, like this. Okay. This kind of bending, here volume decrement, here length increment or decrement, here some angle is coming in. This is called as shear. SHEAR. Right. Shear stress. So three different ways are there that you can deform. In reality, you can deform many ways, but only these three ways are important for us. You have to remember these three. That's it. So longitudinal, bulk, and shear. Three different stress are there. And now we need to understand that which one we are going to study, this or this or this. Then there will be corresponding mathematics. Now, strain. What is strain? Simple. Strain is defined as change in dimension just a minute by original dimension. Sir, I don't understand. You need to get this point. That is, see, we have three different ways of deforming a body. We have three different ways. So each way will have its own strain. Okay. So if you want to go for longitudinal strain, in this case, the force is applied along the length and stress developed is longitudinal stress. In this case, longitudinal strain is defined as length will change, na? Change in length by original length. And observe, in this case, no units. No units, no dimension, because change in dimension, original dimension, both are having same. Delta L, change in length is in meters, length also in meters. So no units, longitudinal strain. Bulk strain I'm taking next. Bulk strain means if I compress the body, the volume will change. So in this case, change in dimension is change in volume by original volume. Now, shear strain. Shear strain. Actually, shear strain is defined as this theta, or we take this is delta x and this is capital L. Observe the amount of length moved, delta x and capital L. So that will be delta x by L. Delta x by L. This is the strain. Try to understand. A body can be deformed in three different ways. These three different ways are leading to three different strains and three different stress. Okay. All the definitions, everything is given in textbook, sorry, in the synopsis, check it. Okay. Now concentrate here. Stress, strain. Stress, strain. Up to now, I think you got it, or no need to worry about it. You may not be able to get anything over there. But anyway, let us continue. Stress is proportional to strain or strain is proportional to stress? Which will cause what? What is the cause? Which strain cause stress or stress cause strain?
Stress cause strain.
That's a problem. That's a misconcept. Stress cause strain, because the point is you need to understand this logic. Stress will cause strain is a misconcept. Kana. I'll explain. Very common misconcept. Everyone, most of the student will have. What is stress? See, I'm taking a rod. I'm going to apply force and I'm going to elongate by applying force. You feel that I am applying force, and force by area is stress. That's what you say, right? But no. Observe, force by area is not stress. Check it. Restoring force per unit area is stress. Means, concentrate here. I'm applying external force because of, sorry, this external force, the rod will elongate a little bit more. This elongation, 1 minute. This elongation, delta L by L, is called as what? Tell me. Strain. Strain. Because the rod got elongated, then only internally there is a force to restore. So stress is internally developed force per unit area. That means if body is not deformed, then it doesn't have any tendency to come back. So if deformation is not there, that means strain is not there, internal force won't develop, so stress won't be there. So observe, stress is proportional to strain. So stress depends on strain, not strain depends on stress. So because of deformation, restoring force is being generated. So deformation is the cause of restoring force. So stress is proportional to strain, not strain is proportional to stress. What happens is that the force, and a student will think external force. You are right. External force is elongating. But stress is not external force, internal force. Internal force is being developed because of deformation. That's the key thing you need to understand. Stress is proportional to strain, but anyway, the proportionality and all these things we'll discuss. Hooke's law says that for small or within elastic limit, stress is directly proportional to strain. This is what Hooke's law says. That is, I don't know what kind of stress you are applying and what kind of strain it is. Longitudinal strain or bulk strain and stress, sharing strain and stress, whatever you want to take it, the stress is directly proportional to strain. That's what Hooke's law says. Stress is proportional to strain. That's not what Hooke's law says. Now, although students get confused, deforming force, restoring force, strain, there is a confusion. But most of the times it doesn't matter because that much in-depth IIT JEE will never ask. That much in-depth IIT will never. So, okay, what I can do is that I can, for time being, for a while, let us continue. It's okay. Right? So you need to remember the stress is proportional to strain. So then let us understand stress strain curve. Let us take x-axis, strain. Because of strain, restoring force will be developed. That's called as stress will be developed. So because of deformation, restoring force is being developed. Okay, that's what the graph will be like this. Concentrate like this first. Then there's a curve like this. It need not be exactly same way, but I can say rough estimation. I can say roughly it is rough estimation. Not exactly same, but it's rough estimation. There are multiple points A, B, C, D, E. There are multiple points A, B, C, D, E, and O is there, O is starting. These are the key points to understand. Quickly we understand. Assume that to get this relationship, what we do is that we take a string, and we rigidly fix at one end. Other end, we attach a pan kind of thing. And we start adding what? Mass over there. By adding mass, you're applying force, right? It will elongate. So stress and strain relation we are going to study in this case. Very, very simple. From 0 to A, it is proportional. So A is proportionality limit. Up to A, it is proportionality limit. That means up to A, it is proportional. Now B. B is elastic limit. Sir, what is this elastic? What is proportional? Concentrate here. Up to A, stress and strain are directly proportional. Right? If the ratio is 1:1, assume that it will be always maintained that. Up to A proportional, but from A to B, it is not proportional. But until B, it is elastic. Sir, what is elastic? That means if you apply some stress here, so some strain, some stress will be developed. If I remove the strain, stress becomes 0. That means the body, if you deform up to this, if you leave it, it will come back. If you deform up to A, if you leave it, it will come back to O. If you take up to this point, something in between A and B, if you leave it, it will come back. Up to B, it will come back to original size and shape. But beyond B, it won't come back to original size and shape. That's a point you need to understand. Beyond B, because after B, what happens is that there will be a 1 minute. There will be a deformation starts. That means the body starts behaving like a plastic body. That means it won't regain its original size and shape. Sir, purila. You assume that there is a brand new rubber band. I think you might have played with it. If you stretch it and if you leave it, it will come back to original shape. But if you stretch it too much, then if you leave, then it won't come back to original size and shape. That means it starts behaving what? Like a plastic body. Same thing here. Until B, no problem. If you apply any amount of stress, any strain, no problem. It will come back to original. Once you go beyond B, I'm taking C. C need not be a particular point. It can be any random point beyond B. Once you go beyond B, what happens is that, observe, it will, check it, have permanent set. That means, just for sake of understanding, I took it up to point C and I left it. I removed the external force. So the body will come back and there will be some permanent set left behind. This is permanent set, PS, permanent set. And this point is F, you take it. So concentrate. If you use the body from O to B, no problem, it is elastic. But after B, it starts doing behaving like some plastic thing. D is ultimate strength. Sir, what about C? Kana C is not a special point. C is some random point above B, below D. Okay. So D is ultimate. Ultimate strength. And beyond this, what happens is that it starts breaking. And at E, it breaks down. E is breaking, fracture point, or if you take it up to this, it will break down. So this is how they behave. And concentrate. Some bodies are more and more plastic. So this region will be long, this will be short. Some bodies are more and more plastic. Then this length will be very, very short or may not be there literally. Most times it will come there, right? You need to understand this small thing, stress strain relation and all. In terms of IIT mains, not much you need to understand. You have to just remember, that's it. Okay. And advanced law probability is very, very low. If it comes as a part of a big what question. So I think you can, all these things. If not, I recommend that you just go through the textbook and understand these things. Quickly, just let me explain. What is rigid body? A body which will not deform under application of any amount of force. Deforming force, externally applied force which will try to change the shape of the body. Elasticity, tendency of body which will regain its original size and shape after deforming or external force is being removed. Plasticity, the body which will not regain, that is plasticity property, and the body is plastic body. So three different bodies are there: elastic, plastic, and rigid. Rigid is not there in the world. Elastic, plastic also won't be there. And some bodies are more elastic than plastic or something like that. Leave it. Restoring force. Once a body is being deformed, example, length is increased, assume, internally there is a force which is developed. So the increment of length is causing the force here. So increment of length is the cause, and the force developed, internal force developed, is action. So that's the thing you need to understand. And now when you think about applying force, you need to apply three different ways of applying force. That is, basic thing is that stress we take. Stress is equal to restoring force per unit area. Stress is what, tell me? Restoring force per unit area. Units are Newton per meter square. Units of pressure, but it's not pressure exactly, not always. Okay. And dimensions is this one, fine. Now, how many ways we can apply stress? You can increase the length, that is called as longitudinal strain. You can decrease the volume, this is bulk stress. And you can change the angle. Tangentially, if you apply, it will bend like this, shearing. So three different ways are there that a stress can be developed. And strain. Now, change in length to original length, change in dimension to original dimension. Okay. So longitudinal strain is change in length, bulk strain is change in volume, shear strain is angle theta. These three. Now observe, we understood that deformation will cause internal force, right? So strain will cause stress. Hooke's law says that within the proportionality limit, stress is proportional to strain. And in-depth understanding of how body will stretch and break, there will be a stage where the rod will break. Sorry. Okay. So that basic study we did it. That's it. Okay. You need to understand this. Now, what is required for IIT JEE? I'll tell you. IIT JEE Mains point of view, around 60% of the problems are from one single concept. That is longitudinal only. Longitudinal only, that depends on most times longitudinal stress and strain. So let us go for that. Longitudinal stress. Remember, we are studying longitudinal stress and longitudinal strain. That means we are taking a body and we are applying force either to expand them or to contract them. That means the length may decrease. Sir, string. Kana, when you take a string, you can't compress them. It will slack. But rods are there na, that can go through compression. Right. So, 1 minute. Either compressive or tensile. Tensile or compressive. Anything it can be. Now we are focusing only on this. We know very well, according to Hooke's law, they are proportional. The proportionality constant, force by area, because stress is force by area, na? The proportionality constant in the longitudinal case is Young's modulus Y. Proportionality constant is Y. Is longitudinal strain, change in length by original length. Now you know very well, force by area can be written as F by A. So this is the formula. Concentrate. We are taking three different ways of deformation, out of which first deformation we studied. Right? Stress is proportional to strain, basic formula. Then that I'm using it. Longitudinal stress is proportional to longitudinal strain. So this is the thing. Okay, right. Now what is my statement is, just don't remember this. In exam, in IDJ means advanced, just leave it. In the examination hall, whatever I discuss, you may not remember. Or you may remember very vaguely. Very vague memory may be there. Okay. Now how to deal with it? How to deal with it? Very simple. Just a minute. Right. It's very simple. Focus here. Any rod can be replaced, rod or string can be replaced with a spring. Over. Entire discussion is over. Any rod can be replaced with a spring. Okay, sir. I don't understand exactly. Concentrate here. Spring case la F is equal to Kx, right? Correct. Here K is there. Here Ya by L is there. So K corresponds to Ya by L. Okay. And observe here, what is X? X is elongation. In our Young's modulus and all these things, we use delta L. Elongation of the length string is what? Delta L, right? X. So observe, when you take this thing, if you go back in this formula, F is equal to, what is K? Ya by L into, what is X? Delta L. Check it exactly, you got the same formula. Of course, A is here, you bring the A into denominator, you get it. So finally, you don't remember all these details. Nothing you remember. You remember any rod, IDJ point of view, single statement. Any rod can be considered as spring. With spring constant K is equal to Ya by L. You have to mug up. X is elongation or delta L also elongation. You can take any one among them. Sir, what are the advantage of it? Now, once you remember this, you don't need to worry about elastic potential energy. Elastic potential energy formula is there. Half Ya by L into delta L square. You don't need to mug up. You know potential energy because of spring? Half K x square, right? Same thing you use here also. But what is K? Ya by L. What is X? What is X? X is delta L. That's it. This is the potential energy. So everything and anything and everything will come exactly fit into the place. So remember, a rod can be replaced the spring of spring constant K is equal to Ya by L. Elongation X is equal to change in length delta L. Over. Remember, for IIT JEE, that's it.